So relief displacement on aerial photographs displaces things on the photograph itself and makes it not like a map. Things aren't in their proper position, and we'd like to correct that. And the way that we do that is through a process called orthorectification. So ortho photos have undergone this process. They've been orthorectified, which is why they make such good base maps. We can see what's going on here. If we have a camera here and we're trying to take a picture downward of these, of course we'll have one point that has no distortion right below the camera, the principal point. But these tall buildings here will be distorted, and they're also they're different in elevation. We want to try to correct for all of that. So basically, what we try to do is take it from something like this, where it's based on one camera, and we try to flatten out the picture to a datum plane where everything is in its proper location, as if we're looking down on this from all of these different directions. The way that we do this is we use more than one photograph on the same area, and we understand what the geometries are. So in this example here, we have one photograph of this area here. Of course, it would also have photographed down in this location here, but this photograph captures this area between A and B, and it understands what the geometry of it is on that photo. And the same with this one here. This is more of a vertical photograph. It's also captured the area between A and B. But now we can take the information from both of these photographs and we can use that in a process called orthorectification. So one important thing to remember about orthorectification is in order to do it, we have to have overlapping aerial photographs. And in this case here, we have two photographs. The plane was flying in this direction. It took one photo here with the principal point here. It took a second photo over here. And we can combine the two of those onto, and there's going to be an area of overlap. These flight paths are typical, or the way that the photos are set up is typically to have 55 to 65% overlap, so that now this whole area here, we can use that area that's stippled with a process called orthorectification to put everything back in its proper position and get rid of relief displacement. With these aerial photographs, of course, each one of them has a principal point, and with this kind of overlap, we can also get an aerial photograph such as this, whose principal point would be the place where this line here crosses with this line, approximately here. And then we can also, if the aerial photograph has enough overlap, we can get the principal point from a different aerial photograph on that as well. So this photo here would have zero distortion here, this photo here would have zero distortion here, and we can figure out the geometry for these entire photographs using orthorectification to get rid of all of the relief displacement. This is, of course, this used to be done by machines, now it's all done by computer, but historically, basically the way that they did that was they took the two photographs and then they would just use the two photographs, looking at them stereoscopically, in order to focus at any particular point. So there would be one location here where these two photographs, depending on how far apart they were focused, and that would indicate what elevation this was at, and then they would work down from there as far as where they could focus on this 3D stereo model and come up with one orthorectified photo that was able to represent the entire area as a true planimetric base map.